All right, y'all. Welcome to Friday. And our lesson today is continuing on with triangle congruency. Yesterday, you took your test on side, 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 and side, angle, side. Well, today we're going to be working on angle, side, angle. So this time, the side is the included side. And then this one would be angle, angle side. So the side that is opposite. That's what we're going to be working on today. All right, so what you're supposed to do to get credit for today is to be taking notes with me. Since you are not in class today, you will submit your notes and your homework. Okay, so make sure you submit both. All right, so this is an example of side, angle, side. So you've got an angle here and an angle here, and then sandwiched between those two angles is this side. Okay? That means we have the included side. It's the one that is in between those angles. It connects them to each other. So that is side, angle, side. So it says if AB is congruent to DE and no, I just messed that up. Just kidding. We're dealing with the angle first. My bad. So if angle A is congruent to angle D, if A is congruent to angle D, now if side AB is congruent to DE, because you want angle first, then you want the side, now we want the other angle. Angle B is congruent to angle E. So if you know that information, you know you've got two angles, one side that's in between, then you can prove that these triangles, A, B, C, and triangle D, E, F, are congruent triangles. All right, so we're going to look at some proofs just like we did last time. So if we look at this first one, here's a sample proof for angle, angle, side. So it tells us in the given information that SQ bisects angle RQT. So if this bisects RQT, that tells us that this angle here and this angle here are going to be congruent based on it being a bisector. It also says that it bisects RST, which is this direction, RST. So again, that means this angle and this angle, I should put two curves, are going to be congruent. We know all of that based on the given. They didn't tell us that, but we know that because we know what a bisector does. So the first one is given. Okay? Then it says angle RQS is congruent to TQS. We know that because of the definition of angle bisector. Again, when you're doing this for homework, you can be using your reference sheet because that reference sheet gives you your options for what you can do. We're talking about an angle, so you would be looking in the angle part. Below, it flips it around. RSQ, TSQ, same thing though. Definition of angle bisector. I misspelled that. Bisector. Sorry. Now, it then says QS is congruent to itself. We know that's the reflexive property. They share that. Okay. And then how do we prove that these triangles are congruent? Well, we have angle, angle, side. So we need to decide, is this side the included side or is it the opposite side? Because that's going to make all of the difference. So what we know is we know this side, we know this angle, and we know this angle. So if this is your situation, then you know the angle touches this here, the angle touches this here, so it is touching the included side. So this is angle, side, angle. Even though that's not what it looks like here on the side, that's okay. You have to make sure you put it in the right order when you write out your proof. It's very important with this lesson because we're dealing with two angles and a side no matter what. All right, let's look at number 2. If we look at number 2, they're telling us about parallel lines. It says that JK is parallel to LM and JL is parallel to KM. So I'm marking those as parallel. Remember, guys, anytime you have parallel lines, you are thinking alternate interior, alternate exterior, corresponding angles. All of that is going to help us find angles because them telling us that they're parallel does not tell us that they are going to be congruent. All right. Now, then we're talking about angles. Angle JKL here is congruent to MLK. What are those? They are on alternate sides. They are within the parallel line, so those are alternate interior angles. Then we have JLK. JLK, so this side, with MKL, this side. So these again are alternate, interior angles. Alternate interior angles. And then again, looky here, we have the reflexive property. So we have an angle, and a side. But is the side included? It sure is. It's in between all of those angles. So this would be angle, side, angle, because the side is included. One more example. We look over here at this. The given information is that angle BAC, this angle here, is congruent to DEC, this angle here. Those are congruent. I'm going to write that in there. BAC is congruent to DEC. So that is given information. And then they also give us that C is the midpoint of AE. Knowing that, remember, if they tell you that somebody is the midpoint, it's the midpoint of AE, so that means that segment AC is going to be congruent of segment CE or EC. Okay, and that is the definition of midpoint. Those stream together. Now, there's nothing else that they gave us, but we know that angles that touch on the nose are vertical angles. So we can say angle BCA is congruent to angle DCE. These angles here are congruent because of them being vertical angles. So now we're ready to write our proof statement. ABC is congruent to triangle EDC. We know that because we have this angle here, and we have the included side. So the side that connects those two. So that is going to be angle, side, angle. All right, next type is angle, angle, side. The difference here is that you've got your two angles just like before. No difference with that. The difference is you see the included side, AB and DE, is not the side that we know. We don't know that. We know this side out here, an opposite side. So it says two angles and a non-included side of the triangle are congruent to two angles and a non-included side. So the opposite side could be either of the sides that's not included. So in this case, angle A is congruent to angle D. Side, no, they did an angle. Angle B is congruent to angle E. And side BC is congruent to EF. That means our triangles ABC and triangle DEF are congruent. So let's look at this proof. Let's look at what they tell us first. The first thing they tell us is that line segment YZ bisects angle WYX. WYX is this top angle of the peak. Okay, so it splits that into half. So I'm going to go ahead and write that. YZ bisects angle WYX. That's given. Because it bisects it, I know that angle WYZ is congruent to XYZ. That is definition of angle bisector. Okay. Then it also gives us another bit of information. It tells us that angle YWZ is congruent to YXZ over here. That's just given information. So I'm just going to type that or write that here. YWZ is congruent to YXZ. Did I write that right? YWZ. YXZ, yep, that's given. So that's the given information. That's what we knew because of the given information. There's one more thing that we need to know. We know about an angle. So we need to know about a side. The side that we know about is the one that they share. So YZ is congruent to itself. YZ, that's the reflexive property. Okay, so that's our reflexive property. They are congruent to each other. That's our side. Now, that side is not included. The included side would be WY. That connects those two angles, but we're not using the included. We are using this side that is opposite that, so it's angle, angle, side. And that proves triangle WYZ is congruent to triangle XYZ. All right, if any time you need to press pause, you just press pause. I'm going to keep rocking and rolling so I can try to get this video done and submitted. All right, so here we go here with our given information. Triangle ABC is congruent, not triangle, angle ABC, so that's this angle, is congruent to this angle, CED. So angle ABC is congruent to angle CED, that's given. Then also we know that line segment AB is parallel to CE. AB is parallel to CE. Now that doesn't tell us that those are congruent, it just says that they're parallel. Anytime we see parallel lines, we should be thinking about vertical angle, not vertical, alternate interior, alternate exterior, and corresponding angles. That's what we're thinking about when we hear about parallel lines. Now, they also told you that C is the midpoint of AD. Okay, so AD, C is the midpoint. Well, before I leave that, if it's the midpoint of AD, that means that AC is going to be congruent to DC. And that is definition of midpoint. I forgot to write in number 3. That's given information. So the given information told us that these two segments are congruent because of the midpoint. Now, we know about an angle. We know about a side. So we need to make a determination whether we know about another side or another angle. Well, the other information that they gave us is about parallel lines. Remember, if you know about parallel lines, you're thinking about corresponding angles, alternate interior angles, alternate exterior angles. So if I were to sketch this out, okay, those would be my parallel lines. And then this is my transversal, which is AD. Okay, so that would be AD. This would be my line segments. So if we look at this, okay, this angle right here is located right there. This angle right here is located right there. What type of angles are on the same side? They're obviously not both inside, so it can't be same side interior. What it is corresponding. Those are corresponding angles. So that's how we're going to prove they are congruent. Corresponding angles. And again, that's on your reference sheet. Let me find that real quick. If you look at this reference sheet, remember that these are the parallel lines, okay? The one that we're dealing with right now is that corresponding angles. Those are corresponding angles. They are in the same location, those pink dots. So I'm going to call that angle BAC and angle ECD. Those are congruent, and that is another angle. So if we look at the angles that we know this angle down here, we know the angle up top, and we know this side over here. Again, we don't know that AB and CE are congruent. We just know that they're parallel. The one that we know is congruent is down here. So this is going to be angle, side, because the side is not included. It's opposite the angles. If I just draw out one of those to make that a little bit clearer, that's what we have. These two angles, angle here, angle there. The side is over here. This is the included side. But we do not have the included side. We have an opposite side. So then you just say triangle ABC is congruent to triangle CED. All right, moving on. Here we go with this one. The information that they give us is that PR bisects QRS. QRS, this angle is bisected. So I'm going to write that. PR bisects angle QRS. That is given information. Because of that given information, I know that QRP is congruent to SRP over here. And that's because of the definition of angle bisector. All right. Then the next given is that PSR is congruent to PQR. That's just given information. PSR is congruent to angle PQR. That's given. Now we know about two angles. Angle. We need to know about a side. Which side do we know? Well, the shared side. PR is congruent to itself, PR, because of the reflexive property. That's our side. It's over here. It is not the included side. The included side would be this one, in between Q and R, but it's not. It's opposite, so that is angle, side, and that would mean that our triangle PSR is congruent to triangle PQR. Alright, next one. We know that LG is parallel to JM. Again, parallel lines. I'm already thinking about these three things because we're talking about parallel lines. So I'm going to go ahead and write that. LG is parallel to JM. That's given. Okay. Now, looking at this situation, if you are getting used to these, that tells us that L and M are going to be alternate interior angles. It also tells us that G and J are alternate interior angles. And then we also know that this is going to be, because they're vertical angles. But, you guys, there is no AAA. That's not one of our proofs. That's not a way that we can prove something. So, that's not going to be our option. We need to figure out who's going to allow us to prove this by angle, angle, side. So, let's look at what they told us with the side. H is the midpoint. Whoops. Of LM. So LM, H is the midpoint. That means this segment and that segment. So LH is congruent to MH. You know that because of the definition of midpoint. And I skipped this one up here. It's given. So we've got our midpoint, we know the side. So let me draw one triangle off to the side so we can figure out who we even need. This is the side that we have. We want the angles that are opposite it. We don't want the included angle. So I do not want this vertical angle here. I want this angle and this angle. Those angles we know because of them being alternate interior angles to the parallel lines. So I'm going to say angle GLH is congruent to angle JMH. So that's this angle here at L and this angle here at M. And that is because of alternate interior angles. Now I'm going to flip it and I'm going to do the one down here, angle G and angle J. And we really could probably just say that. Angle G is congruent to angle J because those are the vertex. It's not shared with anything else. So it's okay to just call it by that single letter. G and J are going to be congruent because of the same thing, alternate interior angles. Now, that proves that our triangles are congruent. LGH is congruent to MJH because a congruency statement here, that's for the side. This one's for an angle. This one's for an angle. So, the side that we know is the non-included side. It's over here. This would be the included side. We do not have that. We have the non-included side, so it's angle, angle, side. All right, now we're looking at our last thing for the day, which is the hypotenuse leg. This only applies to right triangles. It has to have this little box. Has to be a right triangle because if it is, then you know that angle. Okay? So the hypotenuse in this case is BC is congruent to EF. So you have to know the hypotenuse. And then any leg, so this one's AB, is congruent to DE. If that's the case, then you know triangle ABC is congruent to triangle DEF. This only works for hypotenuse of a right triangle, and the leg is anything other than the hypotenuse. So let's look at this example. It says, triangle LMP and triangle MNP are right triangles. That's given information. They told us that, so now we know. And then they also tell us that ML is congruent to MN. That's given information. That, you'll notice, is what they just told us. That is going to be the hypotenuse. So they just told us about the hypotenuse. It's across from the right angle, so therefore it is our hypotenuse. Then they also put here that MP is congruent to itself, which is true because of the reflexive property. Okay? And that's another leg. So we know the hypotenuse, we know another leg, so this is the hypotenuse, this is the leg, so we know it's true based on hypotenuse leg. All right, one more situation. We're looking at this. It tells us that WVX, and YVX are right triangles. So they're telling us they're right triangles. And then it tells us that WV is congruent to YZ. All of that is given information. It also tells you that X is the midpoint of WY. Okay, so the midpoint of this. So if this is the midpoint of this segment, that means these two segments are congruent. Now, we know that they're right triangles, so that's the first thing that I'm going to write. WVX and YZX are right triangles. So since they are right triangles, that's given information. That tells us that we can use the hypotenuse leg. Okay, and I'm assuming how they wrote this, V is in the middle. I'm thinking that V right here is going to be the 90-degree angle, and Z is going to be the 90-degree angle because it's in the middle. Okay, and so from there, the next thing is that WV is congruent to YZ. That is also given information. And then we have X is the midpoint of YWY. That is also given information. So we've got our three givens written down. Remember, based on this given about the midpoint, we were able to determine that WX is going to be congruent to Y. X, that's the definition of midpoint. So, if we look at it, the one across from V right there, that's going to be my hypotenuse. The one over here on the side is going to be my leg. So, we can prove that these triangles are congruent based off hypotenuse leg. Just like that. All right, so this is how we are doing triangle congruency with the others. Okay, you have all these proofs that you are using to prove that the triangles are congruent. So now you have homework. Okay, there are 6 proofs on this homework sheet. So I would like for you I want you to do number 6 for sure. I want you to do number 2. And number 4. So 2, 4, and 6. So you're actually just going to do the even numbers, 2, 4, and 6. You have to do those completely from scratch. They are naked, so you are going to give that your best effort. Some of you want extra practice on your test and quizzes, so if you wanted to go ahead and do 1, 3, and 5, you're more than welcome to. I will give you the key for this entire page. All right, if you've got questions, you know that you can reach out to me. Again, use your reference sheet. Okay, you're doing these 3 on this lesson, and then these are going to be your reasons. Use this reference sheet to help you on your lesson today. I hope you guys have a great weekend. Make sure you get your work submitted to me. Everyone, virtual or traditional, needs to turn in their notes and their homework because you are not sitting in my class today, so everyone needs to get both of those things turned into me. All right. Bye, you guys.